Hello everyone. Today the topic of my video assignment is geometric transformations in OpenCV and introduction to OpenCV. OpenCV, or open source computer vision library, is a powerful open source computer vision and machine learning library widely used for real-time image and video processing applications. It provides a comprehensive set of tools and algorithms for tasks like object detection, facial recognition, and image segmentation. Geometric transformation. We have three main different geometric transformation, that is translation, rotation, and scaling, where translation is shifting an image horizontally or vertically to a new position, that is changing the position of the image from one place to another on a given graph is called as translation. Rotation is rotating an image around a fixed point by a specified angle, and scaling is resizing the image in which increasing or decreasing its dimensions. Other different transformations include shearing, which is skiing an image along one or both axes, creating a parallelogram effect. Reflection, flipping an image horizontally or vertically. Arbitrary transformations, applying a combination of scaling, rotation, and translation to an image. And then perspective transformation, skew corrections, adjusting the perspective of an image to correct for distortions. Object alignment, aligning an object in an image to a specific perspective or orientation. 3D reconstruction, recreating the 3D structure of a scene from multiple 2D images. Like for example, here if we take the image given here, uh, this is this image will be seen in different ways depending on its perspective. Now from this perspective we can see both the sides, whereas if we stand on the other two ends we will see a different perspective or a different side of the image. And then next we have image resizing and scaling. Nearest neighbor, a fast but blocky interpolation method of resizing. Bilinear interpolation, a smoother resizing method that considers the surrounding pixels. Bicubic interpolation, a high quality resizing method that produces smooth results. Line causes resampling, a high quality but computationally expensive resizing methods. Um, Next, image rotation. Rotation angle, specifying the angle of rotation is required for image rotation. These are the required factors: the rotation angle, rotation center, scaling factor, and fill method. Um, for example, for rotating, if we consider this image over here, if we have to rotate this image, we have to check which is the center point uh, which we have to take as the angle of rotation, and how many degrees from that center point we have to rotate the image for the rotation. That is what is the rotation angle. And rotation center is the point which we are going to be considering as the center of the image, and keeping that point in mind we are going to be rotating the image. Scale factor, adjust the size of the rotated image as needed. After rotating, do you want the size of the image to be smaller, bigger? Depending on that, that is what it considers. And fill method is once you rotate, as you can see over here, if once you have rotated this image, here are some empty parts of is there on the screen, whether what should be done with these empty parts, whether it should be filled with the same image in a different way, or whether it should be left empty, will be checked by the fill method. And then image translation parameters are horizontal offset, vertical offset, and fill method. Description for the horizontal offset is the distance to shift the image horizontally. And example, you can consider 50 pixels. And vertical offsets, the distance to shift the image vertically, 100 pixels example. And fill method, as we can as told in the before slide, fill method is once you have moved the image, what should be done with the other empty parts of the screen, whether you want to fill it, like replicate the same image, you want the empty screen black or a custom color. And next we have conclusion and application. Computer vision or object detection, facial recognition, and image segmentation, robotics, vision-based control, navigation and object manipulation, augmented reality, real-time image processing for overlaying digital content, and medical imaging, image analysis for diagnostic and treatment planning purposes. These are the different areas where we can use OpenCV or the geometric transformations using OpenCV. These geometric transformation can be done both on 3D as well as 2D objects. Like translation can be done, translation and scaling and rotation, as well as sharing, skewing, everything can be done on both 3D and 2D objects. And depending on the object, the geometric transformation will occur. That's it on the geometric transformation on using CV. Thank you.